Hello, what's up guys? This is Aviation Sheet Metal Layouts by moi, Arnold. Yay. First we're going to go over some general rules. Rivet diameter. In order to figure it out, you're going to do 3 times your thickest sheet, whatever it is. Rivet length is going to be 1.5 times our rivet diameter, plus grip length, which is the amount of material you're joining together, times 16. And then you round that up to the nearest whole number. In order to do max and min rivets, you'll use a multiplier on a chart. So, like if we had 40 thousandths as our thickest sheet, and we were going to use a 4/32 or 1/8 rivet, our multiplier is 6.2, and we're going to multiply that by the width of pitch. So on here, I should just kind of write, this is whole number. Oh, I have to change it from black. 2 seconds. Alright, whole number. That's supposed to be a H. And then once you get the multiplier on the chart, you're going to take that number times pitch width. And then that kind of gives you your max number of rivets, giving you that multiplier. In order to find min, you're going to multiply by 75%, and that will give you your minimum. Now remember, if it's like 30.1 rivets, then 31 is my minimum. If it's 30.1 for a max, then it's going to be 30, because I can't go up to 31 for a max. So always stay in between whole numbers. Then you're going to choose your layout. So let's just say it was 48 rivets. I could do, let's see, 4 times 12. That would work. That's 48 rivets, right? I could do, I'm trying to think of what else goes into 48. 6 times 8, 48. And then what you'll end up doing after you choose your layout is see if your layout works. So this is kind of like a drawing board. So once you get there, you're going to start testing. So this is all my testing phase to see if everything fits into the rules. So then I've got edge distance, which is from the edge of the metal to the center of the rivet, which is typically 2 times rivet diameter to 3 times rivet diameter. Humans like using 3 times rivet diameter because it gives us some wiggle room, seeing as we're not machines and we're not perfect. So we like to be somewhere in the middle. Pitch is the distance across. So say it was like 8 inches, you'd put 8 minus 2 of the edge distances and you'll get a number. And then divide that number by the number of spaces that you have from your layout. Your number of spaces is going to be 1 less the number of rivets going across. And you'll see as we do a practice one. And then gauge or transverse pitch. If it's unlimited, we typically use 75% of pitch. If it's limited, like I only have a couple inches that I can gauge across, I can't overlap it unlimitedly, then it's going to be the same as pitch, but going in the down direction. So distance down minus 2 edge distances gives me a number. Divide by number of spaces, which will be 1 less than the number of rivets in my rows. So I have to make sure that I fit these rules. As long as my edge distance is anywhere from 2 to 4D, my pitch is somewhere between 3D and 12D, and my gauge, it has to be somewhere between 3D and actual pitch. Gauge will always be smaller than pitch. the same or smaller. If your layout math fits the above criteria, I can rivet the layout. If my layout math did not fit the above criteria, I would change my layout and try the math again. So say for that 48 rivets, my 12 by 4, the pitch doesn't work, it's too close, it doesn't fall within 3D, then I'd have to try that 4 of 6, or 6 of 8. So I'd have to try a different layout. Again, here's my multiplier. The reason why I'm showing you this particular chart, as you can see up here at the top right how it says 2024 T3 Outclad, that is the material you will be riveting together in the shop. So getting you used to this chart. So here's a practice of unlimited. First I have to figure out my rivet diameter. Remember that's going to be 3 times my thickest sheet. So my thickest sheet is 0.051. And I end up with 0.153. Now, in case you don't remember from class, you have 3 30-seconds, 4 30-seconds rivets, 5 30-seconds, and 6 30-seconds rivets. If you do 3 divided by 32 in your calculator, you get 0.094. Sometimes they say 0.096. 0.125 for this one. 0.156. And I don't remember 6 30-seconds off the top of my head. 1875. I'm going to put 188. So that's roughly the rivet size that we're looking for. So seeing as we have 0.153, I'm really close to the 5 30-seconds rivet. So for the rest of my math, I'm going to use the number for the 5 30-second rivet. So now I can figure out my rivet length. It's 1.5 times my rivet diameter plus grip. Remember, grip is these two numbers up here being joined. So I have 0.040 plus 0.051, and I'll get 0.091 for grip, and then times 16. So let me enter that into my calculator. 1.5 times 0.156 plus 0.091 and parentheses times 16. I get 5.2. Remember, for this we have to go to the nearest whole number, so I'm going to grab a -6 rivet. So I want like an AN 970 AD 5-6 for diameter and length. 5 30-seconds, 6 16ths in length. So now I need to figure out my max number of rivets, my min number of rivets, and my intended layout. So remember, for max I have to go get that multiplier. My thickest sheet is 0.051, so 0.051, and I was going to use a 5 30-second rivet, so my multiplier is 5.1. So my multiplier is 5.1. It says it's 8 inches wide that I'm going to pitch across, so I'm going to multiply that by 8. And I already know what I get, but 5.1 times 8 equals 40.8. So I can't go up to 41 rivets. My max number of rivets is going to be 40. For my minimum, I'll do that original number times 0.75, and I find out that essentially, and 40.8 times 0.75 gets me 30.6 rivets. So 31 is about as low as I could go. So I can choose a layout anywhere in between. Let's do 5 by 7. Let's get me 35 rivets. It's nice and even, it's in between. We'll see how it works out. So the first thing to do in our workout, let me underline all this, is find our edge distance. So we're going to do 3 times our rivet diameter of 0.156. And eventually all of this just kind of comes in your head. It's kind of funny how all the numbers get stuck in there when you do so much of the math. That's a really weird looking 8, but I'm rolling with it. 0.468 for edge distance. And then we're gonna have pitch, which we said was going across our 8 inches, minus 2 edge distances. And we'll get some number. So we have 8 minus 2 times parentheses 0.468. You don't have to put it in parentheses, you could just subtract it twice. But you should end up with 7.064. Now what does that mean? If I drew the little layout, so I've got 2 pieces and they're going to overlap each other. And this is where they're overlapping. What I'm saying is, from the edge, I've got to be 0.468 away, all the way around. So I end up with a little box. And I know the distance where my first rivet is and my second rivet is. That's what that 7.064 inches is. So from my first to last rivet is 7.064 inches. Cool. But I want 7 rivets going across there. So how do I figure that out? Divide by number of spaces. If I want 7 rivets from my layout going across, 1 less is the number of spaces. So I'm going to divide that 7.064 by the number of spaces, and I find out in between each rivet is 1.18-ish inches. So from that first rivet, the next rivet is going to be 1.18, and then the next one is 1.18, and the next one's 1.18, and then the next one, and the next one. And that's how you get your pitch. So you should end up with 7 of them going across, edge distance from the edge, and 1.18 in between each rivet. Now for our gauge, remember that's going to be 75% of pitch because this is unlimited. So I've got 1.18 times 0.75. I get 0.89-ish. And that seems to work, right? So my next row of rivet going down will be 0.89 away and 0.89 away, etc., etc. Now to see if that fits within our rules. Well, we know 3D right here is 0.468. Both pitch and gauge have to be above that 3D, which they are. Gauge is smaller than pitch, so that fits that rule. Now we just have to see if pitch fits within the 12 times rivet diameter limit. So 12 times rivet diameter is 1.87, so it does fit within that. I can go ahead and use this layout. Let's celebrate with a smiley face. So that one worked. If it didn't, I would have to go back and choose a different layout. I might have to do 6x6. I might have to do a different number. What else I could do 8x5, do all 40. I could do whatever 32 equals. So this was just an extra page in case I needed it to do the extra math. And onto a limited layout. So here you can see I'm limited. This little overlap area here is the 3 inches that it says lap. And from here to here is the 6 inches. Remember, you're always going to pitch across the largest number. So my pitching number will be 6 inches. Go back to the first things, rivet diameter and rivet length. Rivet diameter is 3 times the thickest again. This time it's 0.040, which gets me 0.12. If you refer back to the rivet sizes, you can see the 4/32 is the closest at 0.125. So 4/32 at 0.125. So this is the number I'm going to use for the rest of my math. Rivet length is 1.5 times my rivet diameter plus grip. Grip in this case is 0.040 plus 0.032, 0.072, and then times 16. I'm just using the calculator right now, and I get 4.152, so round up 5. A -5 rivet is what I'm going to use. Now remember, you can use a rivet cutter to cut it down to the perfect length, so roughly about 4.2 inches to get like the world's most perfect chop head. Just so you know, it is possible. So now we're going to do our max, min, and layout. So for my max, we're going to go back to that chart. Remember, we have 40 thousandths as our thickest, and we're using a 4/32 rivet. So I've got my 40. I go to 1/8 because that's 4/32. My multiplier is the 6.2. Times my pitching distance. Remember, pitch across the longest distance, so times my 6, my maximum. 6.2 times 6 is 37.2 rivets. So max, 37 rivets. I'll take that 37.2 times the 75. And I'll get 27.9 as my minimum. So 28 rivets. I have to pick a number somewhere in between there. Highly like shooting less rivets, so I'm going to choose 30 and go with a 5x6 layout. So it's a nice number. 5x6 should be enough spaces. Let's find out. So I'm going to draw a line just so I know everything above is good. And I'm going to start with edge distance. So 3 times my rivet diameter, 0.375 for my edge distance. Pitch, The same as always, I'm going to take that pitch number, the 6 inches, minus 2 edge distances, and get a number. So 6 minus 2 times 0.375, I get 5.25. Divide by 1 less than the number of rivets. Well, the bigger number going across, 6 inches, I'm going to use the bigger number in my layout, so I'm going to use the 6 for my number of rivets going across. So divide by 1 less than, I'll be dividing by 5. And I'll get 1.05. So again, you can picture the pieces of metal sticking out from here, but that's my overlapping edges. Here's my edge distance. In between that first rivet and the last rivet is 5.25, and going from that first rivet 1.05 inches all the way across, 5, 6, boom. I've got 6 rivets. So I've got 6 columns. Now I have to get the rows, and that's the gauge. I'm only allowed to gauge across the 3 inches, so 3 minus 2 edge distances. Is 2.25 divided by, alright, so if I'm going to have 5 rows of rivets going across, then I need to divide by 1 less than 5, which is 4. And I get 0.5625. I'll just throw it in there. You can't measure down to 10 thousandths and mark. Any mark you put on your metal is going to be thicker than that. So I would have left it at like 0.56 and just use that for my measuring. Now to make sure it fits within the rules, edge distance is at 3D. So that's good. It fits between 2 and 4. Both pitch and gauge is bigger than my edge distance at 3D, which means they meet their minimum requirements. Gauge is smaller than pitch. So let's figure out what 12 times 0.125 is. 1.5 inches. So 1.05 is smaller than 1.5 inches. We are good to go. So I can use this one. Smiley face. If I couldn't use this one, I might have to run with 28, and I could do 7 by 4. Like, say that gauge was a little too low, I'm going to need 1 less row of rivets to widen that space. So I'd have to change that 5 to a 4 and up the number of columns to 7. So if it doesn't work, you just change your layout, which just changes your pitch and gauge math, and it's only changing this divide by part. So if you get a layout that doesn't work, I'm just going to grab a red pen real quick, change your layout, and then change the numbers you're dividing by. That's it. You don't have to start all over from scratch. Those are just the numbers you change. So you guys are going to be doing the Rivet Card. OMG. You can see where it says 3.5. One piece of your metal is 3.5 wide. But that's not where your layouts are going. Your layout is from this edge to this edge, which if you look up here is 1.63 inches. And your overhang, oh, I cut it off. My apologies. It is 5 inches from here to here. So when you're doing your math and you're doing your pitch, I'm going to put it down here. Remember, you're pitching across the 5 inches, that's the number you're going to start with, and you're gauging 1.63 inches for each layout. And you're going to have 4 layouts. The other thing to look out for is I tell you what type of rivet. So if you have an AN 426 AD3, you're using a countersunk field rivet with a diameter of 3. So this is already a 3/32 rivet for rivet diameter. This one's the universal head, 470. So this is a 4/32 rivet, universal. And then if you look right here, it says, oh, and countersink. Both of them, and parallel rows. So I don't care if your rows go up and down, or left or right, or how you end up doing your rows. You could even do cute little diagonals. I like the diagonals, they look fancy. But it's up to you how you decide to do your parallel rows. The third layout, you have AM 470 AD3 and 426 3. You must dimple. Oh my gosh, everyone forgets to dimple. You do not countersink that one. Yes, you're going to use countersink rivets, but they're going to sit in a dimple. And you're going to stagger your rows. So what does stagger mean? So let's put up 3 rows right here. And these are my normal, like where you would put your rivets is at these cross sections, right? So for my odd number rows, that is where I put my cross section. But my even row, it's going to be halfway in between. And there's 2 ways to figure out the stagger. We can always just talk about this when we're in school, but you do half pitch to get the first rivet and then pitch all the way across. Or if you draw a line, grabbing another color, from your first row to your third row, and you make an X across that second line, that X is the center. So that would be where your staggered rivet would go, is the center of that X. And it says use half and half. And then I also have the universal head. Oops, I just kind of crossed that out. Universal head AD5. So this one's going to be 5/32, and they're all universals. The only thing special about these ones is they're staggered. When you stagger, you end up dropping 1 rivet for every even row. So you just have to pay attention that you don't go below your minimum. Choose a number that's higher than your minimum for those layouts so that you can drop 1 or 2 rivets for layouts 3 and 4. Also, don't forget to shoot the countersinks first. So in layouts 2 and 3, where you're using universal head and countersink, if you shoot the universal head first, you will not be able to shoot the countersink. And then you'll have to drill out all those rivets and you're going to be mad at yourself. So make sure to shoot the countersink rivets first. What else do I need to put in here? Let's see, our rivet diameter is given on the sheet. You must find rivet length. You must also find your edge distance and your max and min number of layouts and all that stuffs. So let's try Rivet Card math for layouts 1 and 3. The reason why it's 1 and 3 is it's the same size rivet. If we look at 1 and 3, it is a 3/32 rivet. So my given rivet diameter is 3/32, which you can use 0.094 or 0.096 is acceptable. Rivet length, you're going to have 1.5 times my rivet diameter plus whatever my grip is times 16. Remember to round up. And then I got my max, my min, my layout. I'm going to scroll up to this chart here. Remember, they already told us it's a 3/32 rivet. Your thickest sheet of metal is going to be 40 thousandths, which is 11.1 for a multiplier. So that's what you're going to use as your multiplier here. Times our pitching distance. Our pitching distance is the longest distance, which is that 5 inches. Which means max, I could have 55.5 rivets. Or 55 max. And then if I take that 55.55 times 0.75, now I actually need a calculator. I get 41.625. So the smallest I could have is 42 rivets. Woohoo. Now because my gauge distance, let's go look at that layout again. My gauge distance is really small. So I want a large number going across and a smaller number going down. So I could do, let's see, I like 4x11, which gives me 44 rivets. Let's see, if I did 3, I could do, no, 3x14 gets me 42, but then for layout 3 I won't be able to drop any rivets, so that's out. What else could I do? I could try 3x15, but now I'm getting a lot of rivets going across. So the math might get iffy. Let's see, I could also do 4x12 and get 48 rivets. But I wouldn't want to go beyond 4 rows. I don't think it works beyond 4 rows. You can try it. I like 3 rows, but then 15, I don't know if that works. So you guys are going to have to try to figure that out. So pick your layout. Remember, you've got pitch, which is going to be that 5. Ooh, hang on. You got to do edge distance first. My bad. Edge distance. You're going to want 3 times your rivet diameter, which is that 0.096 up at the top. Your pitch, you're going to do your 5 inches minus 2 edge distances equals some number, and then divide by 1 less rivets. So if I was doing that 4x11 that I like, I'd be dividing by 10, because the bigger number is what's going to be pitching across. So I would divide by 10 in that case, and then for the gauge, I'd do the 1.63 minus 2 edge distances equaling some number, and again divide by 1 less number of rivets. And in that case, if it was the 4x11, I'd divide by the 3. And then I'd make sure that I fit within all of my edge distance, pitch, and gauge rules. And as soon as I find one that fits in those rules, I will submit it to Holly so that she can say yay or nay on the number. Cool? Alright. Alright. Layout number 2. You've got the rivet diameter. They give it to you. So let's look at that. Layout 2, it's a 4. I have a full 32nd rivet, which if you remember is 0.125. For rivet length, you'll have 1.5 times my rivet diameter plus grip times 16. Don't forget to round up to a whole number. Then we've got max, min, and layout. So for this one, I've got a 4/32 rivet. Again, 40 thousandths is your thickest piece of metal. So we're going to go back to the AC 4313 1B chart. Go to my 40 thousandths, over to my 4/32 rivet. 6.2 is my multiplier. And then multiply that by my pitch distance. So I have 6.2 times 5. Oops. That was kind of funny. Syntax error. 31 rivets. Oh my gosh, it's a nice round number. Times 75% for my minimum. So 31 times 0.75. Minimum number of rivets is 23.25. Or 24 rivets. So max is 31, min is 24. Ooh, what layout could I possibly do for this one? Well, there's 5x5, which is 25. There's 6x4, 24. 8x3, 24. Let's see, 26. 3x12. I think that's a little too much, though. We can try it. No, not 3x12. What was I thinking of? 3 times 10 is 30. Okay, so 3 times 10 is in limits. 3 times 9 is 27. Let's see. We did 3 times 8 already. What other 4s could we do? We got 4 times 6. What's 4 times 7? 28. 4 times 7 works. Good. So any of these we could definitely try, layout-wise. Again, because we have such a small number going for our gauge, I don't think the 5x5 will work. I would want to stay in the 3x range. And then seeing as, again, Holly's, a little lazy and doesn't like shooting that many rivets, I would go with the probably 8x3. Because it's 24 rivets. You could also do 3x9, 27. Up to you. But once you figure out the layout that you want to start working with, you're going to get your edge distance. 3 times rivet diameter, which happens to be 0.375. And then pitch will be 5 minus 2 times 0.375. Which gets you like 4.25. Divide by 1 less. Number of rivets going across. So whatever your biggest number is, 1 less than that is what you're dividing by. And then gauge. 1.63 minus 2 times 0.375 equals some number. And again, divide by 1 less. So if it was 3, you're going to divide by 2. Cool. Alright. Layout number 4. This was given to us. Rivet diameter is a 5 32nd rivet. Ooh. Which is 0.156. And you're going to figure out the rivet length. 1.5 times rivet diameter, the 0.156, plus the grip, which is 0.072, in case you haven't figured it out by now, times 16. And round up. And then we're going to get our max, our min, and our layouts again. So our max, remember we have to go get that multiplier. We're going to have a 5 32nd rivet, 40 thousandths, so our multiplier is 4.0. What everybody is trying to get in school, right? So 4.0 times that 5 tells us our max number is 20 rivets. 20 times the 0.75 gets us 15 as our lowest. Remember, it's staggered, so I'm not going to want to go with 15. I want to be at least one higher. So I could do 4 by 4, which is 16, but I have a really small amount of gauge still, so 4 by 4 might be excessive. I can't do 3 by 5 because when I drop, I'm going to lose that rivet, but I can do 3 by 6, 18. Trying to think if there's any others. Let's see, 3 times 7 is 21. I'd technically go above. 3 by 6. It's probably your best bet. The 17 won't do. Well, when you do 3 by 6 and you drop 1 for the stagger, it will be 17. So, okay, that'll work. And then you're going to do the same thing with pitch and gauge. You're going to take the 5 inches minus 2 ED equals some number, divide by 1 less. Same thing with gauge, except for it's 1.63 minus 2 ED equals some number, divide by 1 less. The only thing you might want to know ahead of time is about edge distance. This is the only one where it matters. Edge distance. It's got to be somewhere in between 2D and 3D in order for it to work. For some odd reason, it doesn't quite work with 3D. I think I used 2.5D and it worked. So play around with this layout, find one that works for you, and then remember it's going to be staggered. So you have your pieces of metal, and this is 1.63 and this is 5 inches. So that's my edge distance all the way around. I know where my first and my last rivet is. Once I find out pitch, I'll know where all my other little rivets go. So I'm going to try to draw them the same over here. So I've got my first and my third row. For the second row, if you draw from the first row to the third row, you'll get where the X's cross is your staggered. So it's halfway in between. Or you can do, yeah, let me finish with the X here. Alright, or I could do half of pitch, put my first rivet for my stagger in, and then use pitch distance to find the next rivet, and pitch distance to find the next rivet. Either way works, but you can see how it's staggered. Cool. Alright, that's about it for doing your rivet layouts. If you're having issues, let me know. Double check your math with me before you actually draw the layout. That way I can be like, yes, you're on it. Or, oops, you messed up a little bit, let's figure it out. Cool? Awesome.